So hello ladies and gentlemen. Today we're going to be taking a look at how to find the rule of a sinusoidal function. Now we notice that right here in front of us we have a sinusoidal function. It is not tangential. And we know it's a sinusoidal because it has some kind of a wave. Now we know that all sinusoidal functions either look like f of x is equal to a sine of b times x minus h plus k. Or they look like f of x is equal to a cosine of b x minus h plus k. Now the choice is ultimately ours. And so for the purposes of this particular example, how about we take a look at using the sine function. So our first task is to find one cycle that's going to repeat itself, and it doesn't matter which one we choose. For example, we could use this particular cycle, or we could use this cycle. It doesn't matter. But it has to look like a sine function because we chose to work with the sine function. Now, more often than not, when choosing where to start your cycle, most people will choose something that is very, very close to the origin. And so we'll be working with this particular cycle. So our first task is to find out what our h and k are by observation. And simply the h and k is the starting point of our first cycle. So here we'll notice that the hk value, the starting point of our sine function, is right here. So our starting point is at 0, 1, and that's going to correspond to our hk value. So we can start replacing that into our function. So we'll write f of x is equal to a sine, open brackets, b times x minus 0 plus 1. Our next task is to take a look at the b value and the a value. And we know that the a value is equal to plus or minus our amplitude. And our amplitude is defined as our maximum minus our minimum divided by 2. So when we look at this particular example right here, our maximum is at 4, our minimum is at negative 2, and when we divide 4 minus negative 2 by 2, we get our amplitude of plus or minus 3. Okay? Now we're going to choose whether we want it to be plus or minus 3, just like we chose that we wanted to work with the sine function. Our b value, if we remember, is equal to plus or minus 2 pi over the period. And the period, remember, is defined as the amount of time, or the amount on the x-axis, or on the independent axis, that it takes for a single cycle to repeat itself. In this particular case, our cycle starts at 0 and ends at a value of 2. So our period is 2. So here for our b value, we're going to have b is equal to plus or minus 2 pi over 2. And 2 pi over 2 is just pi. So we have that b is equal to plus or minus pi. So again, we're going to get to choose. But because of the way the sine function looks, it looks exactly like the basic sine function, where it starts off by going upwards and then reaching a maximum, coming down to a minimum, and going back to the center. We know that here we have a choice of either choosing a positive a and a positive b, or a negative a and a negative b. Now, most oftentimes, people will choose a positive and a positive to work together. So we can just write this here as f of x is equal to 3 sine, open brackets, pi x minus 0 plus k. And there we found the function rule of the first function that we were looking at here. Now we just arbitrarily chose 0, 1 as the values for our hk.
but we could have chosen any other values. And by doing so, that would change our sine function. And so let's see how that changes the function, but it's a function that will define the picture that we see, no less. So let's just pretend that we would have chosen this point right here as our starting point. So this would be at 5, 1, which means that the first cycle that repeats itself is being drawn right here in green. Okay, now the values of the A parameter and B parameter don't change because those were relative to the amplitude, which was the maximum minus the minimum divided by 2, and to how often or how long it takes for the pattern to repeat itself. And because we haven't changed the pattern, it still takes the same amount of time. So we have our A parameter as being plus or minus 3, and our B parameter as being plus or minus pi. But now that we've chosen a different HK value, we're dealing with a function that looks like f of x is equal to a sine, because we're still using the sine function, of bx minus 5 plus 1. And now we have to go and choose a value of a and b in a way that's going to represent the green function that we're looking at. So if we look at the first cycle of the function, it looks like a basic sine function that's been flipped vertically, or it looks like the basic sine function that's been flipped horizontally. And it's up to you to choose which one you want. So the starting green cycle looks like it has a positive amplitude and, or sorry, a positive A parameter and a negative B parameter, or it looks like a negative A parameter and a positive B parameter. The choice is entirely up to you. I personally prefer using a negative A parameter, and so I will write this function as f of x is equal to negative 3 sine of pi times x minus 5 plus 1. And this function here is exactly representing the same function as the previous function did, and it doesn't matter which one you choose, neither one is more correct than the other.